Hi, my name is Sarah Hajati, and I'm going to talk to you about Professor Tom Murphy's lecture on the power of physics estimation. That's him over here. He's a professor at UCSD. So basically, his idea was the concept of estimation and how to use it as a tool. He emphasized different global issues such as the energy crisis and global warming, and so that we can utilize estimation and various physics concepts to help press these issues. He was very passionate about global warming, and he also talks a lot about alternative fuels, and he believed that gasoline will run out in the near future. This is a slide from Professor Murphy's lecture. He pretty much used something called Fermi problems to address various situations. It could be from how many piano tuners are in Chicago to how many molecules from Julius Caesar's last breath do you currently draw in on each breath. So it's a really cool tool that he introduced. It can be used right here. When you drop a coffee mug, how many pieces does it break into? Well, you can use values such as the volume of the coffee mug, how many joules of energy is required to break each bond in the coffee mug. You must also solve for how many bonds exist in that coffee mug. And by doing all of this, you can ultimately figure out that the coffee mug would break into 2,000 pieces through the process of estimation. So it's a pretty cool tactic. Another problem is how many kids are laughing so hard that milk is coming out of their noses. Well, if there's 7 billion people in the world and they're expected to live about 60 years, and this usually happens between ages 4 and 10, which is 10% of your life, then this could happen to about 700 million people. Well, it's probably not happening to this many people. So, this normally happens only once in a lifetime. And so, because it can typically last about 10 seconds, we conclude that right now there's approximately 20 people on this earth, or 20 kids, for that matter, who are laughing so hard that milk is coming out of their noses. So it's a pretty interesting thing you can do there. But applying this to global warming and how expected temperatures are rising, here we have a slide from Professor Murphy's PowerPoint presentation, which pretty much uses estimation to see what the temperature change of the Earth will be with regards to the greenhouse effect and how much carbon dioxide is being released into the atmosphere. And he's also taken into account the fact that the ocean has a really high heat capacity. So it takes in heat, but it's really slow to let it go. But through using these numbers, he concluded a 2.6 increase in temperature change, which is very, very significant. And so it really shouldn't be a surprise that the release of carbon dioxides, which is a result of burning fossil fuels, will increase the temperature of the Earth. So in conclusion, through the process of estimation, Professor Murphy has really pressed the idea that we often know more than we think about a problem. And even though in the real world we don't have really tidy numbers to work with, we still can use estimation to come up with numbers that relate to different global issues. And so this lecture was really interesting to me. I thought the fact that he used estimation to back up global issues was a better way than some people who try to press global issues without quantitative information. And as a researcher, I definitely can use what I learned from this lecture because in the lab I'm constantly working with numbers, and I really don't know if experiments will work sometimes, and by estimating and forming what I think will happen quantitatively besides qualitatively, I can use estimation and really see what I expect from the lab and really take those numbers seriously now that I know that estimation is a good tool to use. So after this lecture, I actually visited Professor Murphy's website because I wanted to learn more about his work. And I found something really cool. He's actually working on a project called Apollo, stands for APOCH, don't know how to pronounce that, but Point Observatory Lunar Laser Ranging Operation Project, which is a new initiative in lunar laser ranging that uses a 3.5-meter telescope in New Mexico. And so I looked at his website, I checked out this project, and it's really cool how he's basically trying to build a huge laser in New Mexico. So he's a really interesting professor. So some other lectures that I attended were the lecture on cosmic rays, took place earlier this week, and I also attended the lecture on the history of the universe from the beginning to the end. Thanks for watching.